About technical hurdles to project development, and this session is kind of a melting pot of all sorts of other issues that are related to project development. And if anybody understands project development at this point, it's AVEC, of course, and with Brent Petrie leading the charge. And again, most of us will all know Brent, but Brent's worked for AVEC since 1998, where he manages the development of alternatives to diesel generation for AVEC with hydro, wind, and heat recovery. He also works on energy supply issues with AVEC's largest customers, and he's the program manager for AVEC's many construction projects as an energy partner of the federally funded Denali Commission.
Thanks, Kat. Our first speaker this afternoon is going to be Alan Axworthy, and Alan's an application engineer with Northern Power Systems. He's going to be speaking about the AVEC experience with the Northwind 100 fleet of, we have 24 operating wind turbines right now. Alan's with Northern Power's headquarters in Vermont. He's focusing on the community wind market for them. He's been a key member of the support team, and we've also worked with him quite a bit when we've developed proposals and applications for projects. He has a construction background and has spent some time building facilities in the Pacific Northwest, and also including 3 years building suspension bridges in Nepal with the Peace Corps. He's a licensed professional engineer with degrees, a bachelor's degree, master's degree from Stanford University. So welcome, Alan.
Thank you. Thank you. I'm glad that that Brent's here, because he's the one that knows about all of this stuff. It's actually much of his data that that I'll run through for you. Good.
I might just add that this data that we provided to Alan and others at Northern, a lot of it comes from our operation records. The new wind projects that we've been constructing, the State of Alaska Energy Authority has required that data be collected on those. So we've been collecting data in that format as well as kind of an expanded format.
Good.
So.
Okay. And please, Brent, feel free to correct me when I go through something and don't get it quite right. Very quickly, AVEC's experience with Northern Power Systems 100 kilowatt wind turbines goes back 5 years and change. I guess those projects had to start before 2006. Currently in 8 communities, 24 turbines installed, over 8 gigawatts of total production, approaching 1/3 hours online, and saving over 500,000 gallons of diesel fuel to date. When we talk about the 100 kilowatt turbines in their fleet, there are really 2 flavors, 2 versions. What we called the Northwind 100A was our first generation 100 kilowatt unit. Was the result of actually a lot of work in the late 90s, some research work through NREL, through the National Science Foundation. There were some NASA grants involved as well. Focused on cold weather application. The initial target was Antarctica, and for a variety of reasons, mostly having to do with logistics and getting bumped off the plane at the last minute. Turbines never went down there, but they did come up to Alaska. The 100A was a direct drive unit. That was probably the key, I guess, contributing factor to our approach to reliability in extreme climates, was to remove the gearbox, simplify the drivetrain, and use the power electronics to manage the full power, the conversion of the very, very low frequency generator output all to DC and then all back to AC. We also developed two rotor, I guess configurations you'd call them, for Class 1 and Class 2 conditions. We have some of both units installed in the fleet at this point. Now the NP, the Northern Power 100, is our current model. It's a second generation, builds on what we did with the 100A, so it's still a direct drive, still set up for cold weather application. We added to that a permanent magnet generator that creates a bunch of benefits, a lot of benefits to not having to pull reactive current from the grid in order to excite your generator. It was also put together, we spent a significant value engineering effort in, I guess you'd call it maybe downsizing. We pulled a lot of weight out. We pulled a lot of complexity out and focused it more on the more distributed, the lower 48 community wind marketplace. So to that point, we provide at this point only a Class 2 configuration. So very quickly, you guys are all probably much more familiar with this than I, but the western regions of Alaska and then the Gamble and Savunga sites that are a little bit further afield are where the turbines are. I flagged the orange flags are the 100A sites. The blue flags are the new NPS 100 sites. So very quick lifetime production summary here for each of the different villages. Again, the 100As in orange, the more recent second generation NPS 100s in blue. This is where our total numbers come from. Now these are numbers that we pulled out of our data. They collate actually very closely with the 2010 data that we got from AVEC. So when talking about, we talked earlier, the issue of diesel savings and plant efficiency and all that came up a little bit earlier, and we touched on that a little bit. But there are really a couple of different ways of looking at plant efficiency. One is certainly the overall fuel savings, your overall diesel savings. That's kind of the bottom line number. How much did you use last year? How much did you use this year? Is that number bigger or less related to the amount of energy that you produced? So the key parameters for looking at efficiency as opposed to simply gross or total fuel savings really require that you know how much your wind production is, what portion is that of your total production, and then what's the efficiency of your diesel plant. We talked earlier about the diesel plant, how adding wind can cause your diesel generators to run at a lower load level more of the time, hence decreasing the efficiency of the diesel generation. But you can also look at your total or net efficiency of the whole system, including the wind-generated energy. How many gallons of fuel did it take to produce your total energy? And that's the total or net efficiency. And then the efficiency improvement is the delta between what's your diesel-only efficiency and what is your total net plant efficiency. Does that make sense? So this is my eye chart. It's not quite as bad as my schematic from earlier, but it's, I think, notable to see that the efficiency increase over the fleet for last year, this is strictly for 2010, was a 20% 20%, and over 200,000 gallons of fuel saved in the 1 year. Do you have any particular comments about this or points that you would emphasize on this, Brent?
When we get to, maybe after you're done.
Okay. So for 2011, there are 6 units in the works, 4 for Emonic, 2 for Shaktoolik. It's going to be happening spring and summer this year. That'll bring the total fleet to 30 units, so a continuing investment. Benefits have to do with rate stabilization, village employment. We've had probably 30 villagers through operating and maintenance training at the factory in Vermont. And the empowerment, the morale, the improvement, or the pride that people take. Brett, my boss, was talking about running into some high school students from Hooper Bay who were talking about their turbines and how what they did for the environment. They were pleased to be involved with it and very proud that they had a site. So that's what I have. Brent, any?
We have time for about 5 minutes of questions. Does anybody have any questions for Alan? Yes, Tony?
Why did McCory show 0? Is there issues with those turbines?
Just installed.
Okay.
I mean, yeah, so some of these, not all of the sites operated for the entire year. Some of those sites just came on during the year. I think that was commissioned late in the year in December.
Alan, you say no rate increase across the fleet. What would have been a typical rate increase for communities in Alaska without wind? You know that?
That's a great question. I'm going to have to defer to Brent.
The 2008, we had a very large rate increase because the price of fuel spiked. That price spike didn't play through until our 2009 rates. So our cost of fuel probably was about 25 to 30% more in 2009 than in 2008. However, in Tuksuk and Kasigluk, there was no change in rate because a little over 20% of all of the production in those communities were coming from wind. So it stabilized the price in those communities.
It's a very good metric, community to community.
Yeah. And we're getting more and more of that information as more of these come online. Yes? Okay, any other questions about?
Give Kat some exercise.
Yeah. So Kat's getting her exercise here.
Do the communities that don't have wind benefit from the price or the savings from the ones that do have wind, or is it community by community based on who has the turbines?
Okay, in our case, the fuel savings are for the community, that specific community only. However, we've been involved in a major renewal and replacement project, largely grant funded, for about 10 years. And in 2010, our board of directors lowered our base rate by 2 cents a kilowatt hour. So that's across the board. That's all of the customers that we have, which are about 7,000. But not just because of wind, it was because of some other investments as well. So one more question, and then we'll get on to Peter. Okay, in the back.
I just saw you had like 30 villagers trained. Are those villagers still living in the villages that they first lived in when they got trained?
I don't know the precise answer to that. In some cases, they are. In other cases, I know that we have contractors that work for us, and in some cases, villagers that were trained at Northern Power are working with the contractors, and that contractor is going, you know, they're going to different villages. So, you know, they're not necessarily staying exactly where they were when they were trained. We do find that that training, the training that Northern offered has worked out very well. In addition, we're going to have a later session today where the Alaska Vocational Tech Center will give a little presentation about the training program that they're starting right here in state.